Good evening, folks. I'm Newton Isaacson, and this is Free Body Diagram News. On tonight's show, technology. It's everywhere, it's all around us. And what is a big part of this technology? Cell phones. We use them all the time. Now, a cell phone is only good when it's charged. This one, it's dead. This one's dead too. Useless. But what do? How do you solve this problem when you're in a car?
Car charger, you idiot.
Some degenerates might think you can use a car charger. They'd be wrong, and this is why. When you use a car charger, this is running off the battery. Now, a battery in a car is not constant. Other things are relying on this battery. Say, for example, when you first turn on your car, there will be a surge of energy. However, what if you crank the air conditioning? You'll have a little drop in energy. This means that the energy going to your phone isn't constant, like it would be if you're using a wall charger in your home. What I mean by this is that it can damage the battery in your phone and give it a shorter life expectancy. Another problem with a car charger is that it limits the amount of things you can charge at once. If you have a family of 5, how are you all going to charge your Angry Birds and your iPads and your 8-track devices? So you must be wondering, how can I solve this problem? I'll tell you how. 4 students from Riverview High School have engineered a project which can help you do just this. And this is what they built. The CARGERTRON. And now we're going to send it over to the students themselves to explain in detail this eloquent piece of machinery. For the purpose of displaying each part of our project, we have it set up on the table instead of mounted in the vehicle.
Our device harnesses aerodynamic drag to generate energy. The blades on our propeller are positioned so that air resistance will cause it to spin. They are twisted to take full advantage of the drag and so that it will spin in the proper direction.
When turbine blades capture wind energy and start moving, they spin a shaft that leads from the hub of the rotor to a generator. The generator turns that rotational energy into electricity. Simply put, generating electricity from the wind, or in our case air resistance, is all about transferring energy from one medium to another. Through tests performed by hooking the CARGERTRON up to a voltmeter, we determined that the most efficient place to mount the CARGERTRON is on the front of the car, placing the device under the hood with the propeller on the outside of the vehicle facing forward and the cables running through the hood into the front seats of the car. The voltmeter displayed higher levels of energy in this position than on the sides of the car, and it also seems to be the safest positioning, as it is out of view of the driver as to not cause a distraction, and there's no chance of it flying off and hitting another vehicle.
Our device required a minimum speed of 70 km per hour to generate enough energy to power a phone. The device is designed specifically with road trips in mind, where highway speeds will be constantly higher than this for a long period of time.
A motor is an electromagnetic device that converts electrical energy into rotating mechanical force. You supply electricity to it and it will give you mechanical force as the output. A generator is just the opposite. It converts mechanical energy to electrical energy. You provide the mechanical force, like a turbine for example, and it will give you electrical energy. A DC device will work both as a generator and as a motor depending on what you give as an input. The CARGERTRON uses a 12-volt generator to transform mechanical force from the propeller to electrical energy for charging the phone.
A generator, in the case of the CARGERTRON, is a set of magnets that spin around a coiled wire. The magnets spinning around the wire create an electrical current, providing us with power. Connected to the shaft is a set of gears which transfers that rotational energy further to the charger's generator, creating anywhere between 4 and 6 volts for your phone's battery.
The energy then travels to the capacitor. In a way, a capacitor is like a battery. Although they work in completely different ways, capacitors and batteries both store electrical energy. Capacitors can also eliminate ripples of energy. If a line carrying DC voltage has ripples or spikes in it, a capacitor can even out the voltage by absorbing the peaks and filling in the valleys. A capacitor regulates the energy that flows through it so that the cell phone does not receive excess surges of energy.
Electricity travels from the capacitor to the 12-volt DC cigarette lighter. From there, a cigarette lighter to USB adapter is attached. This enables us to plug in any USB device, in our case, a phone charger.
Ready? Yep. So now that you've seen our project, let's talk about the experience. What you got, Keith?
Oh no, I guess we'll start with how we decided to do this project, the CARGERTRON.
Yeah. So we had the idea of using a form of alternative energy, and we decided on windmills.
We weren't really sure how we were going to use windmills, but we decided it'd have to be something kind of small scale, something that we could actually use.
Yeah, we decided something useful for us would be better for the project.
And we like the idea of trying to solve a problem. And so we decided, hey, wind energy, we can use that somehow. We can charge something. Let's charge a cell phone.
Yeah, because I mean, people are always looking to charge their phone, like at any moment.
All the time.
Yeah. So to start our project, we just did some research about how generators and motors work, so we knew how we could make some energy through a windmill.
We needed to make sure that the energy we were getting from the movement of a windmill could actually be transferred and power a phone.
Yeah. So after we did some research, we went over to Princess Auto to try and find a motor that would work. And
We picked up 2.
So we picked up two 12-volt motors, and we used a drill and a voltmeter to test the volts that they would receive. And we settled on the one with the bigger gears so that it would get more efficient energy.
Yeah, and to figure out which motor was more efficient, we didn't want to just hook up a windmill straight to it and just start testing like that. So we attached a drill to the motor and just fired the drill up and then watched how much power it created on the voltmeter.
Okay, time out for a sec. I don't really know how to verbalize the wiring and whatnot. So the next thing we needed to get was a fan blade. So we picked one of those up at Princess Auto, and it was
Say a command.
it was about this big, and it was metal, and it was heavy. And we tried it out with that, but it was heavy enough that it wouldn't turn the motor, really. It would get going a little bit, but it wasn't getting any momentum. It wasn't spinning very fast at all. And so when we used that, it was inefficient.
Yeah, so we only got 4 volts, and we'd have to go up to speeds of about 110 kilometers per hour, so it really wasn't...
It wasn't practical.
It wasn't ideal for our project at all.
We knew we needed to get something else.
Yeah.
So we did some searching around, and we found the next fan that we found had more surface area, and it was lighter. So it had more for the wind to push against, and it was easier for the wind to push it.
We took apart one of Keith's fans.
Yes.
Yeah. Are your parents looking for that?
No, okay.
Okay, good.
Physics for life.
Yeah.
And so that fan, we got 12 volts, or no,
We were getting about 10
we got
volts.
about 10 volts with that fan going at only 70 kilometers per hour, so it's much more efficient than the other fan.
Yeah, because 70, that's...
It's more ideal.
That's
Easily charges their phone.
Yeah, I guess so. So the next thing after the fan that we needed to get was a capacitor. We went to a lot of places looking for a capacitor, but no one really seemed to have them. So we just kind of resorted to looking in my garage.
We got lucky.
We got real lucky.
The perfect capacitor, 12-volt capacitor, just everything we needed.
Yeah, just lying there on the table. There's a perfect 12-volt capacitor that who knows where it came from. But yeah, it worked good. So we wired that puppy in there.
So after we got all the wiring done and stuff, we wanted to find the most effective and efficient way to put the fan out of the vehicle in order to get the most wind. So we tried a bunch of different spots. We tried out all the windows and sunroof and all that. And
So it turns out the most efficient place was with the motor being under the hood and the fan blade coming out onto the top of the hood. It's also safer for the driver because it's not distracting and easy to mount there, so that worked good.
and it's not going to fall off of the top and hit a flying.
Yeah, basically it's easier to mount there than to somehow strap it to the side of a car.
Yeah.
Safer for other vehicles too.
Yeah. It doesn't look as weird.
No.
Alright, so that was pretty much the process of making our project, and now we actually learned quite a bit making this project.
Wind is powerful.
Yeah, a lot more powerful than we thought.
When we had that fan from Keith's fan from his house and we had that sticking out the window during our trials, that thing was absolutely flying.
Yeah, like at first I didn't think wind was gonna move our thing. Like I was like, it was so hard to turn that, but
it was getting to the point where, well, you'll see in the video, but it's going fast enough that you can't even distinguish the blades from one another.
Yeah.
So we also figure that wind energy is a renewable source of energy, so we should use it more often, like than we do right now in our society.
Yeah, we realized how simple wind energy is and how effective it is, and we aren't using it as much as we probably should be. And also what we learned was kind of that the technology for renewable energy already exists today. Like if 4 high school students can make a little windmill that charges your phone, then the technology must be there, but yet we're still not using renewable energy in the world today. And I guess that's mainly because everyone's just used to relying on other things like their cars and everything else. So I guess people just start to need to start like relying on alternative energy.
Right now we're really dependent on certain sources of energy.
Like
but-
oil. And,
Yeah, oil. And towards the future, we should be moving towards renewable sources like solar energy or wind energy.
especially since the technology's here.
Yeah. And we are in some places, but there's definitely more that can be done.
Yeah.
Oh, yeah.
And we proved just how easy it really is in our project. We were also able to learn quite a bit about the mechanics behind everything when we did the building process.
Yeah, like we had a general idea of what all of our pieces did, but we weren't really 100% sure of how a motor worked.
We
And when
they
you,
work together, yeah.
yeah, and like how a motor can be turned into a generator, and also capacitor. Judged by the name, we had an idea of what it did, but we didn't know that it actually regulates peaks and troughs of energy.
And we were able to put it all together into our final project, and it worked as well as it did. It was pretty sweet.
Oh yeah,
Amen
Like,
to that, brother.
It also just goes to show how you can make whatever you want at your house. Like, just go get some parts and you can really make, like, anything.
oh yeah.
We did it.
Yeah, like, just... The main thing that we take away from this project is that we shouldn't assume that we can't build something just because it's already been done before. Yeah, settle for...
Like, I guess you shouldn't assume that something's already been built to the best of its abilities. You should always try to improve it, because if no one tries to improve other things, we don't get anywhere in the world.
Yeah.